So good afternoon. Today is November 23rd. And Jada, you're pretty close to me. You're just to my right. Can you see and hear me?
Yes.
All right, so this is QM222 Quantitative Methods here at Boston University, and this is it, the last class before break for me. I don't know about for you, but all I have to do is make it through one more hour. Woohoo! And then we have a few more days of vacation. And after that, it's the home stretch. What we're going to do today is Mr. Gomez, welcome back. Nice to see you. I missed you. What we're going to do today is I'm going to share my screen. And we're going, hopefully, can you see the class website? Okay. So what we're going to do today is we're going to do lecture 21, interaction terms. So I'm going to open that up. And then under data files, we're going to do handout 16, drinking and GPA. We're going to open that one up too. So those are the two files we really need today. So let me stop sharing. And let me share the PowerPoint slideshow. So let me know if you can't see the PowerPoint slides. The key slide is this one. What we're going to do today is we're going to do two things. First, we're going to do omitted variables, which is something we did last week. And then this coming today, we're going to pick up interaction terms. And the idea of omitted variables is, did we miss something important? And interaction terms are the effects different for different groups of people? Those are really the two questions we're going to try to talk about today. What we want to do is we want to ask the question, all right, does drinking have an impact on academic performance? Now, let me say Boston University as a whole, the administration, is very much down on drinking. They're very negative on drinking. And quick examples, every week comes out the student alcohol statistics, how many students were dragged off to the hospital, how many students were caught with alcohol, things like that. I don't know, have you ever noticed these things? You've never seen the reports? Really? They just send it to the faculty? Okay. And there are other universities where drinking alcohol is considered not only less of a big deal, but I even went to one university which shall remain nameless, where professors were actually expected once a semester or so to show up in the bar with their seniors and juniors who are over the drinking age, who are legally able to drink, and they were expected to have at least a beer or two with their students. So sort of from the BU perspective of, let me just say the university is not really enthused about alcohol in students in any way, shape, or form to other universities which sort of encourage its consumption. And there's been a lot of studies who've looked at things like the effect of outcomes on students, of how many students get into accidents, how many students die, how many students get pregnant. We're going to look at something a little less dramatic today. We're going to look at, does drinking affect your GPA? Pretty straightforward question. So I don't know, quick show of hands. How many people think that drinking has any impact on your college grade point average? So 2 people online, nobody in class. Most people don't seem particularly interested in this question. All right, I guess I did a little better this morning. So 3 people thought that there's some kind of impact. Here's what we're going to do. We're going to first look at omitted variable biases. And then after that, I'll just show you these slides and then we'll come back to it. We're going to basically look at interaction terms. And then there's actually a paper here that shows the impact by a couple of people scattered all over the country, Pittsburgh, UC Davis, and the Air Force Academy, where they actually come up with findings that are going to look very similar to the findings we have in our data set. So let's stop sharing. And now I'm going to share the Excel spreadsheet. And I need somebody who's real quiet, who does not ever really get any class contribution. This is the easiest question possible. So if you're one of those people, please raise your hand and give us a number from 2 to 22 so I can explain which line we're talking about. Kanat, go for it.
9.
9, perfect. Please give Kanat some class contribution. So the B column, so the A column is pretty simple. It's male versus female, all right? So we just have a binary choice in this particular column. In the B column, we have number of drinks on average this person drinks per week, 16, and their GPA is a 4.0. Woo! Right? So doing really well academically. And if we do a quick pivot table, hopefully you can see the pivot table. I'm going to drag drinks to the rows, and I'm going to drag count of drinks to the values. We see drinking goes from 4 drinks down to 33 drinks a week on average. So what you notice first, at least what I noticed first off, is that the data set only have people who drink. Non-drinkers, teetotalers, are excluded from the data set. Okay? So this is just among college students who are drinking. And 4 drinks a week, relatively small. 33 drinks a week is a pretty large number. All right? So 33 drinks a week. What are we doing here? That sounds like more than a 6-pack a day, doesn't it? Or around the 6-pack a day? A little bit. It's 5 drinks a day, so is that a 6-pack? I don't know. Anyways, a lot of drinking. So here's what I'd like you to do. Step 1, can you run the limited regression? And what's the limited regression? We're concerned about GPA, so we're going to put GPA on the left-hand side. And on the right-hand side, we're going to put a constant plus C1, which is the coefficient, times drinks. So our first step is we're going to run the limited regression. After that, and we'll come back and we'll all check to make sure we get the same answer, we're going to run the full regression, which is GPA is equal to some constant plus B1 times drinks. And what's our omitted variable? Our omitted variable is B2 times male. So we're going to see, did we forget about males? Hopefully we'll all get the same results for the full regression. And then we're going to run a background regression. And the background regression is drinks is equal to some constant plus A1 times male. And then we're going to try and explain what that means. And then last, we will calculate the bias. And the bias is C1. And where's C1? It's up here. That's the coefficient C1 right there. Is equal to B1 plus A1 times B2. A1 comes from here. B1 comes from here. And B2 comes from here. Does that make sense what we're going to do? So I'm going to give you about a 1.5-minute head start, and your job is to do the limited regression. And can you explain the constant and C1 in simple words? I'm going to do limited regression. Can you explain the constant and C1 in simple words? How do you add the tool pack? So, oh, you're on a Mac. Yeah, it should already be selected. So unselect it, close it, then go back in and reselect it again. For some reason, the tool pack disappears like every couple of weeks on my computers. Yeah, it's like just randomly, oh, it's been 2 weeks, we've worked enough. We're taking a vacation. We're going to south of France. Bye. Did that help? Mary? Uh-huh. No, you have to sort of select it and then deselect it. Or oh, you selected it. Okay, so let's do the limited regression. And we need data analysis regression. And GPA is our Y variable, so it's C1. And the X range is going to be the B column. So it's B1 through B219. We have some labels. And we don't want to pick constant and zero. What happens if we pick constant and zero? We're saying if you drink at nothing, right? If you don't ever drink an alcohol beverages, your GPA is 0, which is not usually what we're expecting, right? It's not really Can somebody explain in simple terms what these coefficients tell us? Anybody who wants to volunteer? Tarkan, can you do the intercept?
Yeah, if you have 0 drinks, your GPA will be 3.17.
All right, perfect. So people who don't drink, on average, people who don't drink have on average a 317. So I don't know, it's like close to a 3.2. What's that? Almost a B plus average, I think. Christina, yes, no?
Yeah, I think so.
Okay, great. Christina, do you want to do the drink coefficient or?
Sure. So it says that for every additional drink you have per week, your GPA will go down by 0.02.
So every drink you have, on average, your GPA drops by 0.02. Now that doesn't sound like much, but let's assume that you have an extra 10 drinks a week, which is an extra beer and a half a day. So if 10 drinks, we multiply 10 times 0.2, and that's 0.2. And that's the difference between, say, a 3.2 and a 3.0 GPA, or between a 3.2 and a 3.4 GPA is having 10 drinks a week. Does that make sense? So it's not just, most people, it's like, oh, I had a extra beer this week. Yeah, big deal. But it's like, oh, I had 10 extra beers this week on average. That could be pretty significant, 3.4 to 3.6 or 3.4 to 3.2 or something like that. All right, any questions on the limited? So this is C1. That's C1 right there in our bias equation. Let's do the full regression. I'll give everybody a minute to do the full. And the full regression, for those of you who don't remember, was GPA is the Y and drinks and male is the X.
Professor,
Yes, sounds like Chris.
so I'm trying to do the regression, but it's telling me that I'm getting non-numeric values.
Okay.
I'm doing something wrong.
Yep. All right. So Chris is getting non-numeric values. So let's do it and come up with the same error message Chris is seeing. All right. So what I first need to do is I need to create a dummy variable. And we'll get to your answer in a second, Chris. We'll call it male. Let's first drag drinks over. Drag drinks over. Control X. And I need to create a male dummy variable. And that's equal if, left parenthesis, if A2 is equal to double quote male, put out a 1, otherwise put out a 0. Let's copy that down. We should see a 1 followed by a 0, followed by 2 1s, followed by 2 zeros. Looks pretty good. So now we pick data, regression, pick OK. The C column is GPA, and the X column is D1 through E219. Now, if I don't have labels selected, I'm going to get the error message Chris just talked about. It's going to say regression, input range contains non-numeric data, because it's trying to do a regression using the labels at the top. So there's two reasons you get this message. One, you didn't have the labels button selected, or second, somebody typed some words accidentally over one of the numbers. So for example, I typed the word male here. I typed the word male here and female here. So those are ways that could also bring it up. So if I was trying to run the regression with column A instead of the dummy variable, that would be a second way of bringing them up. I'm not sure which. Chris is giving me a thumbs up. So one of those two was his problem.
It was the second one. Thank you.
Okay, so let's do data analysis, regression. We have labels, and we pick OK. And we get these coefficients, and we get these t-stats. Somebody want to help me out? Who can help me with the intercept? What does the intercept tell us? 3.17. Ashley.
The average person gets 3.17 GPA.
All right, we can actually be a little bit more precise, Ashley, about who this average person is. Are they male or female?
I'm gonna guess male.
Okay. It's where all the X variables are 0. So male is 0 and drinks are 0. So who is this person who gets the 3.17?
Someone who has 0 drinks and is female.
Exactly right. Pat yourself on the back. Please give Ashley full credit for today. So women who don't drink have on average a 3.17 GPA. Harrison has his hand up. Harrison, you want to help me out with the drinks number?
Yeah, sure. So for every additional drink that you have, it decreases your GPA by 0.02.
Excellent. So for every extra drink, and for every extra drink per week, and these are averages, okay? It's not like, oh, I had one extra drink and I killed my entire GPA for the semester. It's like, it's a 16-week semester. On average, I drink 1 or 2 extra drinks. Does that make sense? Do not be like, oh my God, I sipped a beer. I just ruined my 4.0 GPA, all right? For every extra drink per week, GPA drops 0.02. All right, somebody want to help me out with the male coefficient? Emily, you want to help me out?
Oh yeah. So I was gonna say that for males, they have a lower GPA of 0.09 compared to females.
Men have a lower GPA than women. Emily, help me out here. Let's look at the T-stat. Is the T-stat statistically significant at the 95% level?
No, because it's less than 2.
All right, so we think men have a lower GPA, but can we say it for sure?
No.
Now, men and women might actually be the same. And
Mhm.
that's really what the upper and lower 95% say here. Men could be slightly higher. In general, we think they're slightly lower, but really not much difference statistically between them. All right, so we've done the limited, we've done the full. Now let's do the background regression. For those of you forgetting what the background regression is, here's the background regression. Drinks is equal to the dummy variable male. And then the question is, can someone help us figure out what the A1 number tells us? What the A1 coefficient tells us? Chris, go for it.
Would it tell us how much being male drops GPA compared to drinks?
Slightly different, slightly different. Somebody else, Chen?
So the constant means if you are a female, how many drinks are we expected you to have?
Yep. If you're female, how many drinks we expect you to have? And then the A1 tells us, Malia?
A1 tells us how being male impacts how many drinks you have per week.
Right, right. So let's do the calculations and let's find out. Do men drink more than women? Though I think we probably already know the answer. This is a guess. So we'll pick data analysis regression, and the Y range is drinks, D1 through D219, and the X range is E1. And the number we really care about here is that one right there, which is pretty statistically significant. Can someone help me out with this number here in yellow in B18? This number here, Jordan.
If you're a male, you will drink around 21 drinks, or like 4 more than if you're female.
Yeah, men seem to drink about 4 more drinks than female a week. I don't know, does that make sense to people? Does that sound kind of silly? Not silly? In college, men drink a little bit more than women? No? Yes? Maybe? Okay, so I'll be quiet for a minute. Can you create the bias? Can you calculate the bias? We've now done all the regressions. Can we calculate the bias? So what's the bias? The bias is equal to 4.1. Where do we get 4.1? From that background regression. And we want to multiply it by the coefficient on male in the full regression, which is B19 times B19. And the bias I got is minus 0.4, negative 0.4. Did you get that bias? And how did I get that? I multiplied 4. Ooh, sorry, not 4 point. It's 4.1. Because men drink 4.1 more drinks per week than women. Oh, same number, minus 0.4. And what that says is GPA is overestimated, or the impact of drinking on GPA is overestimated because we didn't take into account gender, that men and women drink different amounts. Questions? Comments?
Can you restate what does it mean for negative 0.39?
So when we look at the limited regression, which is right here, and the actual values are here, this drinking coefficient is slightly off. And why is it slightly off? It's off because we're not taking into account the impact of men. That there's actually really a difference between men and women. And the impact is different on men and women. And we really need to take into account men and women. We just can't look just at drinking. I don't know if that helps.
I mean, it's a negative 0.39 means we overestimate the 0.02 or we underestimate.
But we're overestimating because it's a
Okay.
negative number. So Chen brings up a really interesting question. Can we dive in a little deeper and try and figure out the differences between men and women? And so what we've just done is we've done the omitted variables lecture another time. And now what I want to do is I want to do the interaction term lecture, which is the one we had last Friday. So what we're going to do is we're going to go to the data sheet. And on the data sheet, we're going to create a couple of different variables. The two variables we're going to create are male times drinks. And the second one is not male times drinks. And what we're going to run is we're going to run the Y variable is GPA, and the three X variables are going to be male, male time drinks, and not male times drinks. And what are we going to do? Let me stop sharing for 1 second and share the PowerPoint. What we're going to do is estimate this picture, except instead of revenue on the vertical axis, we're going to estimate GPA. We're going to put GPA on this axis. And instead of budget on this axis, we're going to put number of drinks. Small number of drinks per week to large number. Small number on the left, large number on the right. And we're going to, by doing these three regression coefficients, we're going to see, is there a difference between men and women? Now, we already have a pretty good idea of what's going to happen because we've already done some of these men versus women regressions. Which y-intercept is going to be higher, the male line or the female line? Who seems to have a better GPA? Jared? Women. So we're going to find a higher value starting point for females. Now in this graph, the more budget we spend on movies, the more revenue. But we're going to have a very different picture. Anyone have any rough idea what the different picture is going to look like when we do it?
It's going to go down.
It's going to go down. Excellent. The more you drink, the lower your GPA. So we're going to start up here at some high GPA, and we're going to go down, down, down the more you drink. And we're going to see if there's a different slope for men or women. A gentle slope, kind of a flat line, means the more you drink, yeah, there's a negative impact, but it doesn't have much. A very steep slope means there's a negative impact and woo, it's huge. So what we'd like to do is we'd like to figure out the differences in the intercept, and we'd also like to figure out the differences in slope. So I'll be quiet for a minute. Can you create male drinks and not male drinks? Can you fill in the formulas for these cells? Oh, I don't have the Excel showing. Thank you. Excellent job, Casey. All right, so male drinks is pretty straightforward. It's equal to E2 on my screen times number of drinks, D2. Male times number of drinks is just E2 times D2, but your values might be slightly different because your columns might be slightly different than mine. Not male, what we did last time was we did 1 minus E2 times number of drinks times D2. So we took the male coefficient and we flipped it. 1 minus E2 times D2, and we got a 0. And what this does is it sorts the drink column. It takes the 5 and says, which column do you go into, the F column or the G column? It says if it's male, the 5 goes into the left column. If it's female, the number goes into the right. So this 9 is a female, it goes into the right column. 29 and 6 are both males, they go into the left column. We have 2 females, 17 and 12, they go into the right column. We have another male, 12, that goes into the left. So it's basically like you're dealing cards, and instead of giving everybody 5 cards or 8 cards or whatever it is for the particular game you're playing, you're basically splitting the cards up based on males and females using this dummy variable in the E column. Okay? So what I'd like to do is I'd like to run a regression, and the regression is the C column GPA, and then I have 3 variables: males, male times drinks, and male times not drinks. Not male times. Male, male times drinks, and not male times drinks. I'm not, NOT, going to include D. Why not? Because I've already used D. I've already split D up into 2 columns. Putting in D again is redundant. Once again, over-identified, so we don't want to over-identify the equation. So I'm going to pick data, data analysis, regression. I want GPA, so GPA is the C column. So the GPA column is the first one I want, and then I want 3 columns. And the 3 columns are E1 on my computer through G1. Sorry, E1 through G219. We'll pick OK. And we get some numbers. What do these numbers say? Let's deal with the simple one first. What does the intercept say? Jordan, go for it.
Is it the average GPA for a female who does not drink?
Perfect. And what is that average GPA?
3.24.
Females who do not drink have a 3.24 GPA. Pretty good job. Nice job, Jordan. All right, somebody want to do male? Harrison, thanks for helping me out.
Yeah, so would it be that males who do not drink have a 3.0 GPA?
Exactly. Males who do not drink have a 3.0 GPA. Now, Harrison, as a male, okay, do you buy it that men have a lower GPA than women?
No.
And you can actually say statistically why you don't buy it and why.
Yes, so statistically why I don't buy it is because the T-stat is less than 2, so it's not statistically significant.
Thank you, Harrison. So you do not have to worry in any way, shape, or form that your GPA on average should be lower than some female in this class, okay? But there's a chance. There's a chance. And what's the p-value tell us? At the 80% level, we're pretty sure it's higher, but not at the 95, which is usually the standard we use in business. Okay. Anybody want to look at the next two and tell us what the next two say? The next two are the slopes of the lines. So what we've seen is that the intercept is higher. The y-intercept, where the line crosses the y-axis, is higher for women than men, but we're not statistically certain that it exists. Okay? They could actually be the same intercept. But the two things let's change it into blue. These two coefficients are really the whole key to today. And what do these two numbers say? Those are the slopes of the line. Chris.
Is it for every drink a male has, their GPA goes down 0.01, and then the same for females for 0.02?
Yeah. And if we look at 0.01 versus 0.02, what does it say in simple words? Women have twice the negative impact on their GPA from drinking than men. Men have a bad impact. You drink an extra 10 drinks a week, gentlemen, your GPA on average falls 0.1. So if you have a 3.3, you now have a 3.23. But women, if you have a 3.33 average and you drink 10 more drinks, you're going to lose 0.2 of your GPA, is what this says. You're going to go from 3.3 to 3.1. The impact of drinking seems to be the same amount, seems to be twice as much for women as for men. No? Yes? Maybe? This makes sense? It doesn't make sense? So let's do one last thing. And the last thing we're going to do is we're going to make some predictions. So I'd like to make some predictions. And here's the things I'd like to do. We want to predict for a female who drinks 7 drinks a week, basically a drink a day, versus a female who's a heavy drinker who drinks 28 drinks a week. What's the difference in the GPA? And do the same thing also for men. Give you a 1-minute head start. What would the GPA be for a female who drinks 7 drinks? What's the GPA for a female who drinks 28 drinks? What's GPA for a man who drinks 7 drinks a week versus the GPA for a man who drinks 28 drinks a week? "28 drinks is slightly more than a case of beer." Okay, so we do values, and for the intercept, we always give it a 1 because we want to include that in our prediction. Let's do females first. So somebody help me out. In A18, what do we put, a 0 or 1? This is a really easy question. Somebody who hasn't contributed today? Or are they? Mary, go for it. A 0. We're looking for females. So males times drinks is going to be 0. And the last number for not male times drinks is 7. Exactly right. So our prediction, what's our predicted What's our predicted GPA for this person? Equals some product of A17 through A20, comma, C17 through C20. Let's make it formatted nicely. And we're expecting this person to have a 3.09 GPA. So a female who drinks 7 drinks a week will have about a 3.1 GPA. And now let's just change it from 7 drinks to 28 drinks. What happens? Down to a 2.65. Ouch. From 3.1 to a 2.65. Yowza. Everybody get something similar to what I did? So let's do it for the men. Let's do a male who drinks 7 drinks, and then do a male who drinks 28 drinks. So we'll change male to 1. Well, times male times drinks make that 7, and the bottom number is 0. Does that make sense? So our best guess for a male who has 7 drinks is a 2.9 GPA. And let's boost our number from 7 to 28. Pretty serious drinker here. Goes down to 2.63. So let me stop my sharing for 1 minute. And if you actually look at the research paper, there it goes. Does drinking impair college performance? Evidence. Basically, they look at the difference between people who are legally able to drink and people who didn't drink. All right, and what they find is that using all these kind of numbers here, they can actually figure out what's going on, and they see a pretty big impact on GPA, except for one group. There's one number that's positive, and that's if you were in the bottom half of the freshman GPA, right? That basically people who are really poor had really low GPAs as their freshmen. When they get older, they still have really poor GPAs whether they drink or not. Okay? But for everybody else, some really big negative effects. If you were in the top half of your freshman GPA, if you were doing really smoking well, freshman year, by the time you get to be like a senior and you start drinking heavily, you're going to crush your grade point average. I don't know if that helps or hurts. It is the Thanksgiving time where people are interested in eating, drinking, and generally taking a few days off from studying. So I'm basically out of time. Any questions? So what I'd like to say is I look forward to seeing you a week from today, 7 days from now. And over the next 7 days, have a wonderful Thanksgiving. Enjoy yourselves. And most of all, please stay healthy. We only have a few weeks left in the semester. All we need to do is like stay healthy for 3.5 more weeks, all of us, and we can make it. And then hopefully the COVID vaccine will show up. So have a wonderful Thanksgiving.
Thanks, Professor.
Thanks, Professor.
Thank you, Professor.